How you guys doing? So today I'm going to talk about building a dump truck. Dump truck is going to be this one here, and this is going to be a video covering start to finish of building this. From the CAD model to LightBurn onto the Creality Falcon 2, assembly, and the finish. Stay tuned, I'll have chapters and have fun. I'm going to post the CAD files for this and also the LightBurn files as well. Feel free to build this thing yourself and let me know how I did. This is the first time I've done anything like this. First time with a laser cutter, first time really doing anything with wood too. If you like it, tell me down below. This is the workflow that I came up with and tried to figure out, and it seemed to be the best approach. The software doesn't really matter. Like, I'm sure a lot of people are using Fusion 360 now, and I'm pretty sure you can do pretty much the same thing, same workflow as what I've done here in Solidworks. So this haul truck originally was a 3D printed model I came up with, and the idea was to have it be print in place. So it all is printed in one go, and it is all functional. And the idea was that you'd print it on this side with these blue faces, and it would print all the way up, and then that way everything has the wheels and all the things like where there's pivots, it would all be functional. The problem with this model was for the size I had it at, it was very detailed. It is quite detailed, and it made all the support material a real nightmare to deal with. It did, like, I was able to print out maybe 3 or 4 of these in various sizes. I ended up scaling it, and it was a good design to try and convert into a laser cut model because I already had the model pretty simplified already for 3D printing. So a lot of the stuff like these railings and all were already pretty thick. It wouldn't have taken too much to convert this. One of the main issues when deciding on this was, if you look on the bottom here, how we have this piece here that is on an angle. This would not work with the laser cut model because the way you're building up shapes, at least from what I've seen, is you want to keep things more box-like. So let me open up the model of the final laser cut version. And I've applied 2 materials just to help visualize what the end result would look like. Some things, especially like the railings, had to be much thicker. You can see on the bottom what I did here was I converted this to be all flat, so there's no more of that triangular shape to it all. Basically kept the same shape. So if we look at them side by side, they're pretty much, you know, the major dimensions of everything is exactly the same. Just this one is a lot bigger now as a laser cut model. Some of the main things, let me isolate some of this so we can have a better look at this. So this is the bucket. This is like the classic way that I've seen of laser cut toys, how they go together, where they have all these notches and they just fit together. And the way I went about doing this was initially blocking out all the panels. I didn't bother with any of this stuff because this would be the last step. I would just use the material, I would specify material thickness. So this is roughly 5-6 millimeters, the wheels and the main frame. This is like 11 millimeters. Going through, blocking all that out and getting this shape, and I used the 3D printed model geometry as a reference, and I just built over top of it. So once I was happy with the shape of everything, I then went through and, as you saw, I would cut and make these notches. And I didn't bother with trying to keep them symmetrical or keeping a constant distance. I think that actually is better to have them as unique distances. Otherwise, you could be in a situation where, like, for instance, this piece here, it's looking almost the same. You don't want to accidentally put it in upside down. So unique distances made it so parts would only fit in one way, and that would be the correct way. Yeah, after that, you saw that I hid the notches on this side where you see them most. I wanted to try and hide them as much as I could, but I didn't make, like, you can see them over there and over here and stuff, but I didn't really bother with trying to absolutely hide them. Stuff like this where the notches for this pivot here, there's really no way around that. I thought about putting in a piece to cover it, but I decided not to in the end. That's how you make the overall shapes of all this stuff. After that, I went in and added some details. So this is just some split line kind of shapes and stuff on the surface. Same with over here. That was just to, you know, add some fine details. In the end, I didn't use thick fills like this. I found that line work actually worked better. I kept the fills for this because it was quite thin. I found just sharp lines on the laser cutter looked more appealing. After I had the model all finished, I had to get into LightBurn. That was posed a bit of a challenge in the beginning, and what I ended up doing was I rotated all the parts so they're all on their sides like this. And this allowed me to have everything can be basically have a snapshot in this direction and get all of their actual shapes as a DXF file. I had to place them all around. In SolidWorks, this is still a part file, so I ended up converting this into an assembly. So this is the assembly of all those parts, and they're all positioned in a group. So over here is the thicker ones. So this is the 11mm stuff, and then over here is the thin stuff. And then that way, when I get into LightBurn, an easy way of knowing, because once it's in LightBurn, I have no reference of how thick anything is because everything is a two-dimensional shape now. Over inside of LightBurn, shapes they came in, then it's a matter of making your cut layers and all that. So you can see over here, I have 4 cut layers. These ones actually, the line should be, this one here should be, this is a cut out, so that should be at the end. Something like this is a good order. So you do your line work, and then you do your fills, and then you cut out the holes, so the holes are like the center here. You want to do that because once you cut the wheel out, the wheel might fall down, and then you have no way of getting that circle anymore. So having some control over the order of where holes and stuff get cut out is quite important. Getting everything to fit well together. So parts like this, LightBurn has a nice feature called nesting. Or it's not necessarily in LightBurn, it's in an open source online tool. And I'll just show you how that works. If I just take some of these parts randomly, when I export out of SolidWorks, it's going to be in the position of the way parts look in SolidWorks. So doing the snapshot in SolidWorks, the parts are going to look like this in the DXF file. So if we just imagine that this is how the parts come in, and I want them to be placed in a box, what I can do is select all those, and inside of LightBurn, so we got nest selected. LightBurn copies the address, so we'll upload SVG, and then there it is. So once all our parts are in there, we're going to select the shape that we want to use, and we start the nesting process. And what this is going to do is tightly pack everything as much as possible. I'm going to stop this. I'm going to set my space between to be 4mm or 4 units, whatever the SVG is. Run this again, and you'll see that there's a nice distance between everything. And this is a lot more ideal for cutting out. Let's say I'm happy with that. I'm going to stop that. I'm going to download the SVG, jump back into LightBurn. It's asking me to load it back in, so we're going to hit OK. And we select the group now. Now everything is automatically positioned to where it was in this tool, which is called SVGneset. After that, the box around it is no longer needed, and then we're left with this. So I made like a master file, and that master file had all of the parts laid out. I don't know if there's an ability in LightBurn to do this, but I wanted to, for instance, this grouping here, or I want to cut all this out in one go. I don't care about any of this stuff down here. So I made 3 duplicate files. And then I would load them up and just delete everything that was unnecessary, and then position this group to be in the frame there. And that was basically it. On the final design, I went back and you see where it is purple for the fill, which is this one here. I ended up converting a lot of this to the lines which are in green. That was the only change that I made. And then it was ready to be sent to the laser cutter, which in this case, I'm using the Creality Falcon 2. So the board I'm cutting this on is pretty big, so I have the laser cutter just lying on top of it without the feet. So in LightBurn, I have 3 sheets like this. And I think what I'll do next time is cut out the plywood so it fits the dimensions. That way it's just easier to manage inside of the laser cutter. And what I'm doing is doing the fill first, and then I'm going to do some of the etching, and then I'll cut out the small holes, and then I'll cut out the actual individual parts. That way when I'm doing this, etching happens first and nothing moves, and then afterwards the last step is cutting out the actual parts, because once they're coming out, like, they could fall out of position and then there's no way you'd be able to etch on them. I went through various curve settings to try and find the diameter of the laser. So here's one at 0.1 millimeters. This one almost fits. I then went down to 0.05 millimeters, and then this one is, it's a little loose in there. So then halving that, going in between 0.075, and then this one fits pretty good. And this is this is roughly 6 millimeter plywood, and I've tried with the 12 millimeter plywood. Like, the value works pretty good for that as well. Here's the fit between the thinner and the thicker stuff. So definitely the thicker stuff has a bit more charring along the edge, just because it's going slower, it's got to burn through more stuff. This one's a lot cleaner. This is about 6 millimeters. This one's double that. But overall, like you can see, like this pole piece was cut out. The cut all the way through it is nice and sharp. Same with the thinner one here. The fill engraving takes considerably longer than I thought it would have. So next time, if I were to do this, what I would do is move everything that is going to be engraved very close to each other, because it looks like there's no G0 rapids in LightBurn, so everything is running at a constant speed. And all over here on the machine, you can see here, so like when it's going back and forth between the stuff on the left and the right, like it's going at a constant speed. So it's not like it's moving as fast as possible. Maybe there's a setting in LightBurn that can change so that's more efficient, but I think overall just moving everything that is to be cut, to be filled engraved, just move it all to be closer, and I think that's the way to go. Here's my settings for the fill, how they look on the machine. So we're doing roughly 40% at 3300, roughly that one there. So that's how that should look. It's good when you're running this to, like when you're finding the thickness, run it through a bunch of passes, because you'll find that, especially in plywood, the material, like you'll probably have to bump it up 10 or 20% to be able to cut through the majority of it. Because what I find is, as I'm cutting, like a lot of it will cut properly. This one you might be able to see in that corner there. But then there will be spots where just the laser cannot just get through it all. So you just have to bump it up for those outliers. That way you'll be able to get through most of the material. I have the pipe that comes with the enclosure attached to this bigger pipe, and then this is like a big mains voltage fan. And then this way the flow, it's sucking, and it's sucking everything out of the tube. So if there's any holes along the way of this, the negative pressure stops the smoke from coming out, and this works pretty good. So there's the result. I'm pretty impressed with the detail. Like this door here, like that's really small. Let me get my hand in there so you see how big it is. It's that big. Some of the things I noticed is it looks like possibly these are curling. Part of the layer is kind of coming off there. I took out the legs off the machine and I propped everything up with some steel here. Just because I'm cutting on a very large board. You can see it's coming out the side here. Next time I were to do this again, I'll cut the boards to be the size of the build area, and then that way I can raise it off. And because right now the problem I'm having is I have everything raised. You go here on the outside, I do have a gap in here, and smoke comes out the bottom. And by using a smaller piece that's the size of the work area, I would have been able to use this accessory, and this would have helped out a lot. Twofold on this. One is you'll notice that some of these parts, like this one, fall down. So there's a possibility that something, especially a round thing could fall and then rotate, and then that possibly could jam the gantry and everything as it's going around. So you might lose a job if you're elevating everything like this. It helps mitigate like where like all the smoke is happening, and also like I'm cutting directly into the table, so I know the laser is going through this material and then going into the table, so it'll be interesting to see what that looks like. The table I have this on is just scrap material that I was going to throw out, so I made a table instead. But like if you have a nice table, definitely you're gonna want to cut on a mesh like this, because that way you can save your table. So I need to cut out a few more pieces. Hopefully I haven't left enough space here for the sides of the bucket. If not, no problem, I got plenty of material. So a number of these parts, like this piece here, on this side, it didn't look like it went through. And I'm not sure what is happening there. It looks possibly like there might be something really thick within the material, and then that why the laser is not cutting all the way through. Because generally, it does a really good job at cutting everything out. So most things, like especially like all this stuff, like everything just falls out. Something in here, plywood's not perfect, I guess, so it's always good to find out your cut value and then just bring it up by 10 or 20%. Some of these things I'm gonna have to recut because they're just not salvageable, but other ones I can glue back together and it should be fine. The laser cutter did a really good job cutting this stuff. Like some of this stuff, like that is less than 0.5 millimeter right there, that gap there. Like that's a real high aspect ratio cut. And a lot of these turned out really good. Here's a door with some little bit of engraving etching on the surface. These diode lasers, like the beam is incredibly small, and like when they're cutting straight down, like all these cuts are just perfect 90-degree cuts. And yeah, especially like this, like there's no way you could cut this. I've never seen a piece cut like that where like it doesn't, the beam doesn't diverge and spread out, and then that's the backside. Like look at that, it's perfect up and down. Here's some small etching. I might even try going a little bit slower just to get this a little deeper, especially over here. The fill pattern, I have to work on that because it looks like blowing from one side, and I'm not sure what that is. It might just be the plywood that I'm using. It's just not great plywood, something like this. So yeah, you have to really play around with finding a value that works really good to get through everything. But I think in some cases like this, I probably would have never been able to get through that. I probably would have had half the speed just to get through that, and then I would have charred the surface more. It comes down to, some of it's about your settings, but some of it's also about the quality of the material you're cutting. For assembly, I think what I'll do is use wood glue to glue everything together, and then I think I'm going to put polyurethane on everything, and then that should seal some of the stuff like the engraving and also the sides, because this stuff does smell. It's been burned, right? It's been burned with the laser to cut it, so there is a bit of a burn smell, but I can seal all that in with polyurethane, and then also the polyurethane will help retain the blackness to it, so the overall toy in the end should have a lot of good contrast to it. So I've gone through and recut most of the broken things, a lot of these things, and then some of them that had fills, for instance over here. I don't really find the fill in this works that well. I'm just doing an outline like that. That seems to work a lot better. But yeah, overall, everything cuts really nice. Here's what the fill looks like on the darker lines there. But I do find like just drawing a vector line seems to work a lot nicer. What I've been trying is putting lines close to each other to do the same thing. That way it's not like doing a printer style horizontal lines, because you can see them in there. You get a lot of nice contrast on these parts. So many parts. So putting things together, here's how things are looking so far. The edge quality is nice and sharp. So when you get to this point, it's, I guess, more of the fun part, because you're actually assembling stuff. I'm using a combination of wood glue and super glue to put things together. Some of the edges, like this one here, I purposely made it so I would trim this, and I think what I'm going to do is use the CNC machine and stick it in that vise over there and just roll over that edge and make that nice and angled. That gives me the edge I want, and I'll clean it with some sandpaper. Alright, I think we're at the halfway mark. So this is what we got on the base. Looking pretty cool. Everything fitting together nicely. Some more railings to put in. And over there is the bucket. Let's go grab that. I have not tried to see if this fits. Looks like it is. So it's going to go something like that. So far so good. I really like the contrast. Yeah, I just have to get the rest of the parts on. I was intending to sand this flat on both sides, but I don't know if I am going to do that at that point. I might just leave it. The surface does get charred, so you gotta watch with your fingers. So I'm having to wipe my hands all the time. It could just be that it's so thick and it's putting so much heat in there, and that's why it's charring it. Because the thinner stuff, this is around 5-6 millimeters, it doesn't char as much, so it doesn't leave as much residue. But definitely the thicker stuff certainly does. Alright, everything's almost assembled. That last video, I had to quickly take out the top here so I can fit the engine in, because otherwise there was no way I was going to get that in. This part is almost done. The wheels, to get the alignment of all these pieces, you'll see over here, I use some 1, 2, 3 blocks like that, and then that allows me to get the alignment of everything really good. The last step is to use this dowel, this wood dowel, and this is going to be the axles and also the pivot for the bucket, so that can open and close. And I have some spacers in there that I got to put on the dowel pin. So I have the dump truck all assembled now, and I think it turned out great. That's what it looks like. And I got the pink gloves on because I'm going to attempt to apply polyurethane to this whole thing. That should seal in all of the areas where it's been cut, all the dark areas. Should help with smudges and all that, and also the smell as well. I think it turned out great. Let me know what you think. I'm going to polyurethane this thing now. So it's got 2 wheels and it has the bucket, and the bucket opens, and that's how that looks. So I put on a coat of polyurethane. It's been maybe 2 hours, mostly dry. Here's the look of it. Polyurethane does a really good job of sealing in all the black where it's cut. Works really well for that. You don't get anything on your hands now. And yeah, gives it a bit of a shine to it. I still have to do 2 more coats of polyurethane with sanding in between them, because like it is got a bit of a rough surface, and you could probably see it in the reflection here. If you're doing a finish such as this, I would suggest doing all of the light colored surfaces of wood. Do that first and then tackle the darker areas, because darker areas will tend to want to bleed into the lighter areas, so you don't want to do it all at once. I did the wheels all at once, so they are a bit darker than the rest of everything. And if I were to take a paintbrush and then go onto the top of this, I would leave strokes, and yeah, you'd be able to see that. So there it is. Here's the final result. Pretty happy with how the polyurethane came out. Gave a bit of shine to it. Everything's nice and smooth now. And polyurethane is gonna hold up pretty good. It's not gonna leave any marks or anything on the surface. Thanks for Creality for sending a laser cutter so I can build this thing. And I know they came out with a new, I think it's a 40 watt laser. So that would be pretty interesting to try. It'd probably get through this thicker wood a lot quicker. And I think it's also much better for doing stuff like stainless steel, which is very interesting for me. I think if I was gonna do another one of these kits with movable parts like axles and stuff, I'd actually use real ball bearings in there, so things would be nice and smooth. Same with the wheels, so everything would roll a lot nicer. But for purely a wood-only toy, this works really well too. My son will be happy that I got this video done, because now he can play with his truck. So that's it for this video. That was my take on building a laser cut toy and on a Creality Falcon 2. There it is. If you guys are interested in this machine, I'll have links in the description. And if you're also interested in building one of these toys, I'll have links in the description for that as well. And I will see you guys next time.